Hello, hello. My name is Nilay Panchal, and I'm a principal product manager on the Oracle Autonomous Database, which is our flagship fully managed cloud database. For all you Queen fans out there, this is an appropriately titled High Availability and Disaster Recovery presentation on Autonomous Database, or ADB, where we will actually move past some of the basics and dive into some of the more advanced features that make recovery on ADB so easy, as well as keep the autonomous database up and running to meet your business availability requirements. So here I'll walk you through a brief introduction of autonomous database just for better context. After which we'll get into the weeds of keeping your database and its connected applications up and running. So what is the autonomous database? The autonomous database uh, puts together the decades of database automation in the Oracle database that you know and love, including such things as automatic storage management to manage your database data files and control files and defragmentation of space, automatic SQL plan management to identify runaway queries, and more recently, automatic indexing and partitioning that have come into 19C that make managing your data even easier. This coupled with the infrastructure automation that we've also built for over a decade over Exadata, things like Smart Scan to offload SQL processes to storage servers, storage indexing for better and faster retrieval, uh, better network resource management, and stronger isolation, which is important in the cloud, so that every database you actually provision provides you with the performance that you would expect over Exadata. So these two sets of automation combined with our cloud operation automation is the crux of autonomous database, where we use fairly sophisticated algorithms and machine learning to predict outages and diagnose logs to fix automatable problems or alert the necessary operating team. So how does this work? Let's look at some of the key elements in the life cycle of a database. For provisioning, Oracle quickly deploys a mission-critical database on our Exadata infrastructure in the cloud, a platform optimized for the Oracle database. So the database is created on a real application cluster, a rack cluster, so it can scale out storage and CPU seamlessly, while also protecting the database in case of a server failure. In order to protect the system against a complete failure, we also automatically back up your database nightly, as well as have an option to create an always up-to-date replica or a standby, which we'll actually look into deeper in later slides. Securing the database. Once provisioned, the system actually does need to be secured. After all, being on the public cloud has its own security challenges. By default, we encrypt all the data in the database, but encrypting the data at rest is not enough. All connections to the database are fully encrypted as well. To ensure systems are not exposed to any security vulnerabilities, we also apply security patches as soon as they're available. And finally, while managing the database for you, for the optimum security, we lock down access to the operating system, and Oracle applies all the operating system storage, virtual machine, and database patches, and even upgrades when your business is ready for it. Oracle diagnoses all problems, and we actually use machine learning to help us detect and diagnose issues. For example, we continually monitor the database cluster and look for any unusual changes in behavior. And if an anomaly does occur, we're able to compare that behavior to a known set of issues. If a match is found, we automatically apply the fix known for that problem. And if not, this is automatically escalated and a service request is filed to our cloud operations team to look into immediately. So let's look at some of the autonomous database deployment models that you have available to you today. On the left-hand side, we have the public cloud. And starting with autonomous database on shared infrastructure, which will be the focus of our presentation and our feature talk today. This is targeted towards line of business users, small to medium businesses, as well as enterprises, with having the flexibility to be able to scale down to as small as one OCPU and 1 terabyte of storage, all the way up to 128 CPUs or even 300 CPUs if you really needed it. So there's elastic workloads and the ability to basically scale as you need to. Um, the second deployment in the public cloud is autonomous database on dedicated infrastructure, which is targeted towards enterprises that have a larger requirement and would like to reserve Exadata machines just for their enterprise, which does provide you with more operational controls in terms of maintenance activity and access, since it is reserved for your particular enterprise. And then on the right-hand side, you have Cloud at Customer, which is autonomous database in your private cloud behind your network and is not connected to the internet at all. The two deployments there are your Exadata machines, which are similar to your dedicated infrastructure in the public cloud, but behind your private network, also targeted towards bigger enterprises, but that cannot use the public cloud for compliance reasons. And then, of course, we have a private region for those very large enterprises that have a huge amount of migration happening from their data center into a private cloud. And in this final introductory slide, let's look at the type of autonomous databases you may choose based on your workload requirements. So we have ADW, or Autonomous Data Warehouse, for warehousing type workloads, which was our first ever workload type ever released many years ago, and is primarily used in reporting tools, analytics, querying over data lakes, and even machine learning. Next, we have ATP for autonomous transaction processing, which is for OLTP as well as mixed type workloads. They may be more appropriate for transactional work, application development, and is also often used with real-time machine learning processing. Our third ADB type is AJD, which is Autonomous JSON Database, which is a lower cost database more specific for users with applications or data streams that work primarily with JSON data. And this provides an easy to use REST API to basically pass through, manipulate, and query JSON. And finally, we have Apex, which is available also as a lower cost standalone service. And if you're familiar with Apex, provides a quick and easy interface with drag and drop functionality for low code application development. And to note here, for users that require JSON and Apex functionality as part of their OLTP data pipeline, JSON and Apex functionality is also available in ATP, in autonomous transaction processing. Okay, so now let's dive into the meat of the functionality that makes autonomous database so reliable and continuously available, not to be brought offline by planned maintenance activities that have traditionally been disruptive, nor by unplanned outages like or data or network interruptions. So as I mentioned before, ADB runs over highly available Exadata infrastructure, and it actually comes with an SLA guarantee of 99.95% uptime. Um, Exadata is, of course, an extremely mature and fault-tolerant product, right? With industry-leading triple mirrored storage, storage node redundancy. And since we use real application clusters or rack to create tightly coupled clusters under the hood, we are able to support full ACID transactionality without compromising on high performance in ADBS. Also part of this software layer that helps guarantee this level of uptime is redundancy in the load balancers and connection managers that make sure that the database can always be connected to. Even though there is so much heavy machinery under the covers, ADB provides complete infrastructure transparency to the user. So in just a few clicks or an API call, It takes over the burden of instantiation over Exadata in a totally machine location agnostic manner. A really key feature here that our team has been mindful of since its inception is the ability for ADB to stay online and usable during any planned maintenance event. So patching is completely automated, and the underlying cluster management takes care of bringing up new database instances transparently when required during patching. The database looks continuously available to your applications, and along with a feature named application continuity enabled, which we will talk about more in a few slides, it runs completely without interruption. This also means that your database will always have the latest security patches, which is amongst the most crucial and often overlooked steps toward preventing downtime, especially in on-premise environments. If you have used ADB already, you will have noticed as well that ADB instances come with published maintenance windows. So you're well aware, well ahead of time when patching is going to occur on your database. Upgrades are rolling as well. So when it does come time for you to upgrade your autonomous database from 19C to the next database version, it will be a few simple clicks and little to no downtime. So we've talked about the availability that is built into ADB by its powerful software and hardware infrastructure. But now let's talk about your data, specifically problem scenarios such as data corruptions or even unintentional or incorrectly committed changes. Flashback is available for you to rescue your data in Autonomous Database in most forms. You may query or compare your current data with your older data to find a mistake using flashback queries, or you may actually turn back time and use flashback tables to recover a table or a set of tables even to a timestamp in the past. You may bring back a table from the dead using flashback drop, or even use flashback version queries to compare rows within a given time interval and display such versioning in your application if necessary. All of these database features are available to you in Autonomous Database. Moving on, what if your data corruption wasn't just localized to a few tables, but your whole database had been incorrectly updated or tampered with by a buggy application and needed to be recovered? I mentioned automatic backups before. Every autonomous database automatically, without any user action required, takes full triple mirrored backups in the background, along with daily incremental backups, hourly archive logs, and minutely partial logs, even to minimize any possible data loss. These backups are kept for 60 days for no additional charge and are stored and managed by Oracle in the Oracle Cloud Object Store, enabling you to be able to restore to any timestamp within the past 60 days with a single click. You may also clone from that available backup to provide a historical version of your data set to a user that may require it. In addition to automatic backups, you may also optionally create manual backups as restore points to your own Oracle Cloud Object Storage bucket, if you so choose to, or if your company has such a compliance requirement. Manual backups are also retained for up to 60 days and can be used to restore from or clone from that backup as well. Since your applications will now no longer be halted and will be working even through patching or upgrades, which are now online with the database available, we will want to protect our applications against connection drops, both during planned maintenance schedules as well as through unexpected or unplanned outages. Our first step in ADB to hiding outages from our user application is a feature made possible via the connection manager named FAN or Fast Application Notification. FAN is enabled by default and notifies and therefore avoids stalling applications for long network waits. So this can actually drastically reduce network wait times from minutes to seconds or even seconds to milliseconds. In addition to FAN, application continuity can be easily enabled over autonomous database, and we mentioned this before. This can be used to drain connections and load balance during planned maintenance, or as drawn out on the right here, to reestablish a dropped connection to the autonomous database, and even replay in-flight uncommitted work when possible. By replaying in-flight work, the application can usually continue executing without knowing that a failure even happened. And this is a crucial part of high availability for applications connecting to the database. So application continuity is inbuilt in autonomous database and is built over maximum availability architecture best practices, MAA best practices, which is Oracle's best practices blueprint for high availability technologies. Um, the great thing about application continuity is while it requires some configuration in the database, which is fairly simplistic, it requires no code changes on your application's end. And if you're already using it, it works identically across the board from on-premises or other cloud database offerings in Oracle as well. Um, there are two configurations of application continuity as described here, um, just application continuity and transparent application continuity, which I'll explain on the next slide. The application continuity configuration works over Oracle connection pools and tracks session states to basically replay in-flight work, which we mentioned before, and therefore simply hides any dropped connection or uncommitted work from a user application. So transparent application continuity also rebuilds session state and is able to replay in-flight transactions for uncommitted work. But from Oracle Database 18c onward, it's able to work with and without connection pools and can actually work with it without traditional begin and end request boundaries, which are the markers that bound the units of work that a database is currently doing. So TAC is a really great resource to be able to mask hardware, software, network, storage, as well as session errors. All right, so we talked about localized errors, full recovery from a backup, which in some cases could take hours, as well as masking any outages from your unsuspecting applications. But now let's get our beak wet with the ultimate fail-safe disaster recovery with autonomous data guard, and to explore how we can recover our database as quickly as possible, even during the worst unplanned catastrophic events. Autonomous Data Guard allows you to very easily, in just a few clicks on the UI, enable a standby database, which is basically an identical copy of your source or your primary database, which is constantly keeping up to date or refreshing data from the primary database. So this standby database is basically kept ready and available to be swapped in place of the primary during an unplanned outage, which is also called a failover. So enabling standby databases with Autonomous Data Guard, basically, as mentioned here, guarantees a better RPO and RTO on your autonomous database so as to meet your business's critical needs. And for those who don't know, the RPO, which is the recovery point objective, is an organization's tolerance for data loss after which a business's operations start to get severely impacted. Usually, this is expressed in minutes, and we want this to be as low as possible, right? And the RTO is the recovery time objective, which is an organization's tolerance for the unavailability or the downtime of a service after which a business's operation starts to get severely impacted. Also, it's usually expressed in minutes. and we want this to be as low as possible. We will talk more about the RTO and the RPO of Autonomous Data Guard as we go along with the slides. So moving forward, we have two types of Autonomous Data Guard or ADG standbys available today. The first is a local autonomous data guard standby, which we released over a year ago now, uh, and is literally a single click to enable a standby database. It is that simple. As the picture here depicts, it's within the same region, right? So the standby database is provisioned in the same region and it pulls over the database redo logs in the background, which basically means it refreshes the data from the primary database every minute or so. And since the local autonomous data guard is within the same region, it is extremely fast and seamless. Since none of your mid-tier applications above the database need to fail over and they can simply reconnect. However, this of course does not protect you from any complete regional disasters, such as an earthquake or a flood, right? Uh, and cross-region autonomous data guard is a new feature that I myself worked on that we released only a few months ago. And as the picture shows here, provisions a standby database in a different region than the primary database. The differential redo logs are sent over from the first region to the second as the standby database refreshes data from the primary. But in the scenario where the primary goes down, you may simply fail over to the standby database in the second region once it's available and continue running your database and other tools seamlessly. As you may expect, if your mid-tier application stack and other resources are also running in the Oracle Cloud region where the unfortunate disaster occurred, you would have to fail over that mid-tier as well to be able to use it and connect to the database. For the optimum protection, you are able to create one local standby as well as one cross-region standby to take advantage of the speed of local ADG while protecting your business from regional failures with cross-region ADG. So let's dive in a little deeper into each of these types of standby databases in Autonomous Data Guard. Beginning with local autonomous data guard, as we talked about before, local is a simple one-click enable autonomous data guard standby database and protects you from outages within the same region by creating a standby database on a different Exadata machine. If the region has more than one availability domain, then that standby database is provisioned in a different availability domain as well. This is an active passive standby database, which means that the standby database is constantly refreshing from the primary and may therefore be lagging behind it by a couple of minutes. Local ADG is really fast and effective as it provides automatic failover functionality, which means that if there are continuous failed incoming connections and the database is detected as down, ADG will automatically fail over to the standby database with no user action required and zero data loss guaranteed. Once the primary becomes available again in a few seconds or minutes after the failover, then connections to the database may simply resume and work as before. No new wallets are required after this failover to connect to the database, and even peripheral database tools such as Oracle Machine Learning and Apex in the database will simply continue to work with the same URLs that were used to connect to since it is a failover within the same region. Now, if for some reason, such as a network or a storage kind of failure, if for some reason the automatic failover did not succeed, then you may have to manually fail over to the standby database with the possibility of a few minutes or seconds of data loss. And as I promised before, the RPO, the recovery point objective with local autonomous data guard enabled is 5 minutes, which means there can be a maximum of up to 5 minutes of data loss. And the RTO is 2 minutes, which means that there should only actually ever be downtime worth 2 minutes before automatic failover is able to kick in and fail over to the standby database. So now let me walk you through a simple example of what this automatic failover we just described looks like. So this is the screen for when the autonomous database may be unavailable in the case of a failure. Um, and in this situation, you can see that the autonomous data guard, the role is currently the primary role, and the status is enabled, whereas the standby database is available and the primary database is unavailable. And the two databases are in the same region, hence this is local standby database. So very soon, automatic failover would kick in, and the primary database would then go into this updating state um, while it is going in while an automatic failover is occurring. And then in just a few minutes, it's as simple as that, and the primary database simply becomes available again. Um, and the local standby will then be recreated to then become available again for if there was to be another failure in the future. And as I said before, with automatic failover, we have no data losses guaranteed. And once this is done, your applications will be able to connect to the database again, as well as the tools such as Oracle Machine Learning and Apex, and all those will immediately be available once this automatic failover is complete. So cross-region autonomous data guard has many similarities with local, of course. It is also a simple one-click enable and will protect you from complete region failure by creating a standby database in a different region that's available to you and selected by you. Um, this tool is an active passive standby database as well. We do not support automatic failover though across regions, since failing over across regions is more impactful than failing over locally. For example, the URLs for tools such as Oracle Machine Learning and Apex will be different in the remote region. Um, Also, often users may want to fail over their mid-tier applications along with the database to the other region for optimum performance. So you may manually trigger or test the switchover or failover button either on the database console or via an API call when required. For the same reason, if you have both local and a remote standby database available, we always recommend that you fail over to the local standby first. Of course, if there is a complete region failure and the primary database is down and the local ADG are simply not available, you are still safe and protected. And a simple failover to the remote standby will get you up and running in no time. Because there is no automatic failover here, and we are in fact failing over across regions, the RPO with cross-region autonomous data guard enabled is 5 minutes, and the RTO, the recovery time objective, is 1 hour. And similar as before, as we looked at the automatic failover process, if the primary database is unavailable, you will all have the option to manual failover either via the UI on the console as shown here, or you can also call the API for manual failover. Of course, when you are manually failing over, you're accepting some potential data loss, which we do try and minimize when manually failing over as part of that process. And so for my final slide, this is a little deeper in the weeds, but for anyone that's actually using Autonomous Data Guard right now with cross-region and is behind a private endpoint, this is a little public service announcement. If you are using a virtual machine to try and connect across regions, you may need to set up VCN peering for remote private databases. And so I suggest you click this article and read this blog post, and it will really help you out. And that's a wrap. This is just a little summary slide to recap what we went through today. We learned about the SLA that ADBS guarantees, the 99.95% availability. We learned about patching and upgrading that's completely online without any database downtime. We found out about Flashback and full database restores for data corruptions or any incorrect updates. We also found out about application continuity and how it makes connections between apps seamless and hides any interruptions from users. And finally, we learned about autonomous data guard and for better RTO and RPO and protection against regional disasters, we would be enabling cross-region and local autonomous data guard. Thank you for your time. I hope you did learn something today. Here are a bunch of ADB learning resources. You should be able to access this presentation in the description wherever you're watching this. If you haven't already, I strongly suggest creating an always free ADB account and take an autonomous database out for a spin. The Live Labs learning platform is a great resource to access workshops that have been developed by product managers as well as developers about autonomous database as well as other Oracle products. And of course, feel free to follow me on the Twitter as well as the rest of the ADB product management team. We're constantly posting about ADP new features and again, as well as other Oracle product features as well. Thanks.